Okay, so today we are working on section 7.1. This is integer exponents. First of all, when we look at integers, we are looking for both numbers that can be either positive or negative, but they are whole numbers. So they're kind of our counting numbers as well. So we could say -4 or +8. Those are all integer numbers, but numbers like 8.5 or -4 and 1/3, these are not integer numbers. So we're looking for integer exponents, essentially exponents on numbers that are either positive or negative. So let's go back a little bit to some information that we've done in the past. First of all, what is an exponent? Well, an exponent is that little tiny number above another number. So here is the base, and here is the exponent. This is all important information. That little tiny number is the exponent. And what does that tell us? Well, it tells us how many times we need to multiply 4 by itself. So we'd essentially say 4 times 4 times 4 times 4 times 4 times 4 times 4. So 4, 1, 2, 3, 4, 5, 6, 7 times. And the answer, whatever that may be, would be our answer to this 4 to the 7th power. So now let's look at these other little examples. We have 3 to the 1st. We can rewrite that as saying just simply 3. So the answer of 3 to the 1st is 3. We have 3 to the 2nd. We have the 2nd, which tells us that we are going to be multiplying 3 2 times. 1, 2. So our answer to this would be 9. And 3 to the 3rd, we're going to be multiplying 3 how many times? 3 times. How exciting. So 1, 2, 3, and our answer to this would be 27. And we could go on and on and on. Now our question for this is, we know how to deal with a positive exponent, but now we need to also figure out what a negative exponent does. So a negative exponent, let's look on here. A negative exponent, this is directly from your book, by the way. A negative exponent, what does it mean if it's negative or 0? We need to figure that out. So essentially what is happening is every single time we have an exponent removed, if we had 5 to the 5th and we were to take 5 away and it was now 5 to the 4th, we are essentially dividing by 5 each time. So if we divided by 5 again, we'd have 5 to the 3rd, which is 125. We divide by 5 again, we get 5 squared, which is 25. And if we divide by 5 again, we get 5 to the 1st, which is 5. That all makes sense. We've done this before. So if we were then to say, okay, I want to find 5 to the 0, let's divide by 5. And what do we get? 5 divided by 5 is simply 1. Now let's take that number and we're going to divide it by 5 again. That essentially, if we look at these exponents, they have gone down by 1 each time. So now we're subtracting 1 from 0, so we have a negative exponent, 5 to the negative 1st power. And if we divide 5, or whoops, not 5, if we divide 1 by 5, essentially this operation right here, if we divide 1 by 5, we are going to end up with a decimal. So let's figure out what decimal we have. 5 cannot go into 1, but 5 can go into 10. So 5 can go into 10 2 times, and I'm going to put my decimal point up there. It can go in there 2 times, so I can then subtract that and say 0. Oh, and now I have a bunch of zeros. So it is the answer 0.2. That, if I were to write that as a fraction, we could essentially say that it's in the that 2 is in the tenths place, so we can say 2/10, and that can also be rewritten as 1/5. Well, that's interesting because when I see 1/5, I'm looking for 5s in all of this stuff. In all reality, I have now 1/5 here, so 1/5 is the answer to 5 to the negative 1. My negative has told me essentially that this 5 right here is in the wrong place. It's in the numerator where it should be in the denominator. Let's see if my theory holds true for this 5 to the 2nd. So I'm going to give myself a little bit more screen. So now let's look at this 5 to the 2nd situation. 5 to the second. We essentially need to take this answer to the first problem, 0.2, 2/10, and we need to divide that by 5. So let's add some more zeros to there. So 5 cannot go into 0. I'm going to put my decimal point up there. But 5 can go into 2 0 times as well. And now let's look at how many times can 5 go into 20. Oh, it can go in there 4 times. 5 goes into 20 4 times and it becomes 20, 0. So now I have 0. So essentially I have 0.04 or 4 hundredths. So let's put that into fraction form. 4 hundredths, it's in the hundredths place, so 4 over 100. I know 4 can go into 100 25 times, so I can say 1 over 25. So my answer right here, 1 over 25, is right there. And if I look at 25, that's technically 5 squared. So goodness, this 5 squared has been placed into the denominator. It's no longer in the numerator. We're going to play around with this concept a little bit. This is going to be some fun stuff. It's pretty exciting. Alright, so now let's take this over and let's actually look at some of these integer exponents. Let's understand what we've just done. So essentially this is also in your book. It says right here a 0 exponent. So there you go, a 0 in your exponent place. That essentially is going to get us an answer of 1 every single time. So 3 to the 0 equals 1. But 123 to the 0 power is going to equal 1. Let's look at this. Negative 16 to the 0 power equals 1, and 3/7 to the 0 power equals 1. Every single time you have a 0 exponent, you are going to have the answer as 1. It could also be simply, you could say x to the 0 power is 1. Okay, it'll always be 1 because essentially you have had before x to the first power, that equals x. If we were then to divide x by itself, we get 1. It makes sense. So essentially we are finding out x to the 0 power. So that's how that one works. Let's now look at this other property that we have going on. Our other property, the negative exponent property. Essentially, if we look at this, a non-zero number raised to a negative exponent is equal to 1 divided by that number raised to the opposite exponent. So here we have 3 to the negative 2, and that is equal to the 1 over 3 to the 2 power. 1 over 3 to the 3 squared. So it equals 1/9. So you're just squaring that 3. Be very, very careful. Remember, exponents are directly related to the numbers or the letters that they go with. If you had x squared, or maybe 4x squared, this squared only goes with the x. It does not go with the 4. So essentially you have 4 times x times x. You do not have 4 times 4 times x, unless, of course, there was a squared on that 4. But in this case, there wasn't. So now we have the next problem. We have 2 to the negative 4. Another way we can write that is 1 over 2 to the 4th. That negative sign tells me this 2 is in the wrong place. It's in the numerator when it should be in the denominator. So 2 to the negative 4th, that can be rewritten as 1 over 2 times 2 times 2 times 2, or 2 over 16. So that's one part of this whole concept. So we're going to do a couple of practice problems now. Okay, so here we have 4 to the negative 3rd exponent, and we need to simplify this. We need to make it so there is no longer a negative exponent. That negative exponent is screwing us up. So this can be rewritten because I see this negative sign here. This is telling me that the 4 is in the wrong location. So it's in the denominator, it's in the numerator when it should be in the denominator. So I can rewrite this as 4 to the positive 3rd power. Now, is this completely simplified? No, because I have a number here. It's not a variable, so I can actually multiply this out. I now have 1 over 4 times 4 times 4, which essentially equals 4 times 4 is 16, and then if I were to multiply it by 4 again, we've got 64, so 1 over 64 is the answer to that particular problem. Let's do another one. We have 7 to the 0 power. That 0 power tells me that I'm going to have 1. Simply 1. Essentially, if I were looking at 7 to the first power, that equals 7. So 7 to the 0 power, remember every time you decrease by a power, you are essentially dividing by that number. So 7 divided by 7 equals 1. So my answer is 1 for that problem. Now, here we get into that tricky bit. I know we were having a hard time with this before. Negatives and parentheses and negative exponent, and exponents and that sort of thing. And now it's compounded by having a negative exponent in there, and that's always fun. So we have negative 5 raised to the negative 4th power. This negative 5 is inside the parentheses, so everything inside that parentheses is going to be multiplied over and over and over again. And this negative exponent is telling me that this negative 5 is in the wrong place, so I can essentially say 1 over negative 5. I'm going to keep it in parentheses, raised to a positive 4th power is what we're looking at. So now I can rewrite this as saying 1 over negative 5 times negative 5 times negative 5 times a negative 5. Now, is this complete? Is this finished? No, I have a ton of math I can do. Negative 5 times negative 5 is a positive 25, and negative 5 times negative 5 is a positive 25 again. And 25 times 25, if I plug that into a calculator, I get 625. There's my answer. Now here's that same problem. It looks like the same problem at least, but what's the difference? There's no parentheses. So really this negative 4 is multiplying just a 5. We can essentially look at this 5 as being negative 1 times 5. So the 5 is what is being multiplied over and over and over again. So I'm just going to leave the negative out in front, and I'm going to rewrite this as 1 over 5 to the positive 4th. This 5 is in the wrong place, and we know it's in the wrong place due to that negative exponent. So now we can rewrite this as saying negative 1 over 5 times 5 times 5 times 5, and since we've already done the work on this problem, that was a really bad arrow, since we've already done the work on this particular problem right here, we can say it's 1 over 625 as our answer. So, oops. 1 over 625 is here. Oh, and this should be a negative because there was a negative right here, so that needs to carry into our answer. So, there is a couple of practice problems for this. Okay, so now we are going to play around with simplifying actual situations, actual equations. So we have 7 times w to the negative 4th power. First of all, we need to decide where that negative 4th power is going. Does it apply to the 7? Does it apply to the w? Or does it apply to both? In all reality, we can write this as 7 times w to the negative 4th. And if we can write it like that, that means that w is the only thing that that negative 4th is related to. It's attached to this part of the term. So let's rewrite this. We have 7. And I'm going to separate this out so it's very obvious. W to the negative 4th power. 7 times w to the negative 4th power. This negative 4 is telling me that the w is in the wrong location. It is in the numerator when it should be in the denominator. So we can rewrite this now as saying 7, which is going to remain in the numerator because its power is technically 7 to the 1st power, over w to the 4th. So this is final answer for this particular problem. Here is our next problem. We have negative 5 over k to the negative 2. We have been dealing with problems where the negative exponent has been in the numerator, or been affecting a term that is in the numerator, but now this situation we have that term in the denominator. That negative does the same exact thing. It moves things from the numerator to the denominator, or from the denominator to the numerator. So in this case, this k to the negative 2nd needs to go into the numerator. That 5 is going to stay there, and as of right now, there's a division problem happening, so this turns into a multiplication problem. So we have k squared. This k has now moved into that numerator, and the squared goes with it with the negative sign disappearing. last problem. This one's a little tricky. We have a to the 0 power, b to the negative second over c to the negative third, and d to the 6th power. My first thing that I'm going to do is I'm going to try to simplify this as much as possible. If I look at this a to the 0 power, I know from a little bit before, any number to the 0 power is going to be equal to 1. So it doesn't matter what a is at all, it's just going to be equal to 1. So this whole term kind of just disappears. We know it's there, but it just turns into a 1. So what remains is b to the negative 2 over c to negative 3 d to the 6th. Now let's look at all of these terms that have a negative exponent. These negative exponents are telling me that this number that they are attached to, the b or the c, the variables they are attached to, should be in the opposite location. They should be, if they're in the numerator, they should be moved to the denominator, and vice versa. So this b to the negative second, that should be moved to the denominator. And this c to the negative 3, that needs to be moved to the numerator. So we can rewrite this as saying we have still this d to the 6th. Nothing's changing there. It's all positive exponents is in the denominator. And then we have b squared times d to the 6th. And we have c cubed, or c to the 3rd, in the numerator. And now we have final answer. I hope this helps, and I hope this has proven beneficial to watch. Thank you.